All right, so here we are on day 2 of our factoring review week, mini unit on factoring. And the next type of quadratic factoring we're going to look at, or the next type of factoring we're going to look at, is factoring by grouping. And then we're going to take that and expand it to factoring quadratics when the leading coefficient is greater than 1, when the a coefficient is greater than 1. So first of all, let's look at factoring by grouping. We're going to start out looking at this one, 2x squared plus 8x plus 3x plus 12. It's the first time we've seen one with 4 terms. There's no greatest common factor in this quadratic above. Now, you may notice that these two are like terms, and you may be inclined to want to combine those like terms, but we're not going to do that because for us to get an example of factoring by grouping, we want those expanded, and we'll see why a little bit later. But there's no greatest common factor in this quadratic. But if we group the first 2 terms together here, and then we group the second 2 terms together here, then we can see a greatest common factor. So if you notice, if we group these first 2 together, we have a common factor of 2x. And then if we look at the second grouping, we have a common factor of 3. So we're going to factor out in the first grouping, we're going to factor out that common factor of 2x. And that leaves us with just x plus 4. So the 2's reduce out, your x's cancel all except for the 1, and then 8x over 2x gives us 4. So we've grouped the first 2 terms together and factored out a common factor. We're going to do the same thing here with the second 2 terms. We're going to factor out that common factor of 3, and that leaves us with x plus 4. So then what you notice is that we now have 2 grouped 2 terms. So here's a term here, and here's another term here, and each of those terms has a common factor. Those 2 terms have a common factor of x plus 4. Let's see. We have x plus 4 here, and we have x plus 4 here. So we're going to factor out that x plus 4, and that leaves us with 2x plus 3. And that is not right. That's interesting. So the factored form is 2x plus 3 times x plus 4. So then let's look at another example. Here we have 4 terms, and that's going to be one of the telltale signs that you might have factoring by grouping if you have it already broken up into 4 terms. So we're going to group the first 2 terms together, and we're going to group these second 2 terms together. And then out of the first 2 terms, we're going to factor out a 3x. So we're down to here. We factor out that 3x. And when I divide both by the 3x, that leaves me with x plus 2. So here, here we have x, and then here we divide those out and get 2. Here we factor out a common factor of 4. So here's the 4 that we're factoring out, and then that leaves us with x plus 2. Then you'll notice you have a common factor of x plus 2. So you factor out that x plus 2. Let's do that. Factor out that x plus 2. Pull it out here, and then that leaves us with 3x plus 4. So the factored form is x plus 2 times 3x plus 4. Now here's one. I'd like you to maybe pause the video if you're watching this for the first time and try to do this one on your own before we do it together. So we want to group the first two terms together, group the second two terms together, and out of the first two terms we see that they have a 3x in common. And then out of the second two terms we see that they have a 4 in common. So then when I factor the 3x out of the first two terms, that leaves me with 3x plus 2. And then when I factor the 4 out of the second two terms, that leaves me with 3x plus 4 times 3x plus 2. If you've done it correctly, and if it will factor by grouping, then these two factors should actually match. So then your final factored form is going to be the shared factor plus the leftover pieces, 3x plus 4. What you're really doing is you're factoring out another greatest common factor of 3x plus 2. Bringing down that common factor here, and then dividing out, and that gives you 3x plus 4. All right, again, try the next two. Take a minute, try the next two on your own, and then we'll do them together. Just pause the video. All right, so hopefully you've practiced these on your own. We're going to group the first two together, the second two together. These two terms have in common a 5x. So I'm going to factor out the 5x, and that leaves me with x plus 2. These two terms have in common a 2. Factor out that 2, and it leaves me with x plus 2. If you've done it correctly, these two terms should match, or these two factors should match. And so you write down the factor they share, and then the second factor is the leftover pieces, 5x plus 2. So the x plus 2 comes from there, and the 5x plus 2 from there. And again, let's look at it here. I'm going to factor, group these two together, group these two together. From the first two, I'm going to factor out a 2x. That leaves me with 2x times 4x plus 3. And then the second two terms don't have anything in common, but you can always factor out a 1. And then we have the two matching factors, 4x plus 3. So we write down the two matching factors, or write down the matching factor, and then the leftover piece, 2x plus 1 as our second factor. And that's factoring by grouping. Got 4 more to try, so I'm just going to go through these pretty quickly. Got these two that match, and the leftover part becomes the second factor. And the next two, going to factor out a 3x. And then write down the factor they share, and then the leftover factor. So we've got the x plus 1 is shared, then the 3x minus 10 is your second factor. And finally, the last one, factor out a 3x, factor out a negative 1, and they share the common factor of x plus 2, and the leftover part is 3x minus 1. And that is factoring by grouping. That's a really key component in what we're going to do next when we combine the AC factoring method and we have an A value that's not equal to 1 anymore. So, and that'll be the next part